Welcome back to 7th grade science, where we'll be learning this week about motion. Motion is a change in the position of an object. In science, motion is incredibly important as motion happens in things as large as planets to objects as small as atoms and molecules. So then the question is, what is position? If I were to ask you, where are you right now? You could answer that in a couple ways. I'm in front of my computer, I'm at my house, I'm outside, I'm in Durham, I'm in North Carolina, North America, planet Earth, outer space, maybe not outer space. Because physics is such a wide branch of science, there are many ways that you could describe your position, and we won't worry about that right now. What's important is to know where you're talking about in frame of reference. Frame of reference is a group of reference objects whose placement can be compared to each other to determine motion. So in this clip right now, what you can see, there is a camera right there. Blink, 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 blink. There's me, there's this pen. And so we're going to use this whole video here as an example of frame of reference. You could say something is, my finger is close to my forehead, or my finger is farther away from my forehead, or close to the camera. If I were to ask you, where is this pen in this shot, how would you describe that? You could say it's in front of my face, in between my fingers, somewhat close to the camera. And that totally works because now we have a bunch of objects which can be used as points of reference to describe where something is or its position. Motion can be described with a reference direction. Some examples of direction would be north, south, east, west, up, down. And those are all ways to describe an object's motion. So let's use an example. This pen in this video is going up. Mr. Hammond, up in relation to you, or up in relation to Earth, or up in relation to the moon? I'm confused. Good point. We should talk about relative motion. Relative motion is an object's motion in relation to another object. And relative motion is determined by frame of reference. So here on Earth, when people say up, they tend to mean away from the Earth. So in the question that you had, I would say up in relation to planet Earth or people on Earth. Thanks, Mr. Hammond. Good question. For example, a person in a moving car is in motion relative to a person standing still. In the same way, a person in a moving car is not in motion relative to another person sitting in the car. So motion is relative to the point of reference that you're using, whether that's the person at the stopwalk, which you'd be moving fast towards them, or if your point of reference is the person in the car with you, then you would not be in motion because you're both moving in the same direction. You're both in the same position when you start as when you end. Which brings us to distance. Now, distance is a measure of how far an object has moved. Let's say an old man is on a journey, and it's a winding one that finally takes many turns and ends up at its destination. If an object is moving in a straight line, the distance is the length of a line between its starting and ending positions. In science, the meter is used as the standard measure of distance. This is then divided into kilometers, which are used for longer distances, or centimeters, which are used for short distances. Now, while our gentleman may have gone a long distance, displacement is the direction and distance from the starting point to the ending point. So you can see that he wasn't displaced as far as he traveled because the distance he took, the red line, is much longer than the distance from the start to the end. But as they say, life is in the journey, not in getting to the destination. The speed of an object is a measure of how long it takes an object to go from one place to another. In your life, if it takes you driving in a car 1 hour to go 60 miles, then you could guess that you went around 60 miles an hour. Written down like math, speed looks like distance traveled divided by the time. So if it takes you 60 minutes or an hour to go 60 miles, then you would end up going 60 miles in an hour, or 1 mile a minute. And that's about enough information to cram into your brains for one video. So if you have any questions, please send me an email or talk to me over Zoom in our next meeting, but feel free to reach out before then. Bye!